Hello, this is Mark Hosky, Control Engineering Content Manager here with Gus Gremillion, Siemens Digitalization Solutions Consultant. And we're going to talk about advantages of implementing edge computing.
Yeah, hey, Mark, thanks for having me on. So my name is Gus Gremillion. I studied mechanical engineering at Texas A&M University. And after that, I started working at Siemens, where I've now been working for about 5 years. I've worked primarily in our motion control divisions. We're dealing with, drives, CNCs, and PLC-based controls. And now for the last 3 years, I've been in our machine tool digitalization group, where we're helping companies implement Industry 4.0 strategies, including dealing with products and concepts such as digital twins of your machine tools, shop floor analytics, and machining process improvement.
Thanks, Gus, for the introduction. And now we'll get to a few questions about edge computing. Please tell us how you define edge computing as it applies to industrial automation and controls implementations.
Sure. So at a high level, what edge computing comprises is collecting data from your shop floor, whether it be from your CNC machines, PLC-based machines, or sensors, and processing it, quote unquote, near the machine. So you're taking this data, processing it, and providing valuable insights before you're necessarily pushing it up to your upper level systems, whether it be your MES or your data lakes or your server-based environments. It's really taking the data at the shop floor, processing it, and gaining insights near the machines.
Great. And so how is edge computing different from other computing options that are typically used for industrial automation and controls?
Yeah, so historically, the first realm that we really had computation was directly in the control itself. On PLC-based controls, you'd start implementing custom logic. In CNCs, you could implement custom scripts or use your own custom defined variables. Then, in the last 30 or so years, we started to see server-based computations where you might be starting to push data to your own servers that are storing data on premises. And then in the last 15 or so years, we started to see migrations to cloud computing, where data is being sent from the shop floor directly to the cloud. Where edge computing is different is that instead of being one giant hub like you would with a server or in the cloud, you're having these devices down at the machines, processing the data coming directly off the machines before that data is pushed out to your other systems. So instead of having one big aggregated area where you're sending all of your network traffic, you're doing this computation and processing in a distributed manner out on your shop floor.
So then when are edge computing options advisable for use over other controller or computer options?
Yep. So edge computing, I would say it's primarily used to address new use cases that have not already been filled by server-based systems or cloud computing. Edge computing is well designed to be integrated into what we call brownfield environments, meaning where you already have existing machines. Because with these edge devices, it's going to open up new applications and use cases that you can address. So historically, when you're dealing with these machines that are already on the shop floor, they might be constrained in terms of the resources they have available for computation. You bolt on one of these edge devices, you can start to bring in that data off the machine and offload that processing directly onto the edge device. After you've processed that data, you can then provide feedback directly to the machine and then out to your upper level systems as well. Beyond where I'd say, beyond brownfield environments, edge computing also makes a lot of sense in use cases where you have high data throughput. So if you're thinking of sending data out to your on-premise server or to the cloud, and you're dealing with data that you're collecting thousands of times per second, you're going to start to eat up your network bandwidth and your data storage very quickly. With edge computing, that data gets sent simply to this industrial PC sitting near the machine, processed on the edge device, and then you might just have some summarized insights from that data pushed out to your upper level systems. So as an example, you might log data during an entire machining operation for a given part. And then on the edge device, you would process that data to come up with a report to tell you basically, is this a good part that we just produced, or do we have some anomalies going on during the machining process that we need to alert our maintenance department or quality engineers that we've got something going on with this work piece that was just machined. Edge computing allows you to gather that process data at a very high frequency, come up with valuable information to get to provide from it, and then make those insights available to the people who need it.
So how are Siemens edge computing solutions different than other edge computing options out there?
There's a few differences between, I would say, our solution and what other players are offering in the market space. First and foremost, a lot of other players have, I would say, generic applications and tools available on their edge computing devices. That, or it's simply a canvas with which users can develop their own logic. Something that's different with our solution is that we have some ready out-of-the-box applications that you can use on the edge device as soon as it's installed. So this isn't something where you're having to put the hardware in, start to figure out exactly what you're going to do with the data and how to, format the data, and then actually develop that yourselves. We're able to offer tools ready out of the box. They're going to provide you value on your shop floor using our Siemens Industrial Edge for machine tools. Beyond that, a few other benefits I would say with our solution. One is it is an open platform. So beyond just what we as Siemens offers, we have a freely available software development kit so that anyone who wants to develop their own edge apps can do so and deploy it to their edge devices. And then with our edge device, we're able to leverage, especially with our numeric CNCs, high frequency data capture off those machines to really enable these new use cases that I've alluded to in terms of analyzing the machining processes directly at the machine, or starting to track machine health, where you're actually looking at the mechanical characteristics for the components within your machine tool, beyond simply tracking things like motor temperature. We're looking at things like the actual load you're seeing on your machine while you're machining.
Are there other points about differentiation that you'd like to cover or explain?
Yeah. So first and foremost, our edge computing platform is Industrial Edge for machine tools. As I mentioned, it's an open ecosystem for people to develop their own edge apps that they like and to put into the device beyond what we at Siemens ourselves offer out of the box. And with this platform, we've designed it from the ground up to really, one of the big aspects we're trying to address is cybersecurity. We have a number of different features built into the device that are going to essentially lock down the accessibility to the device and the risk of malicious actors getting access to it. This ranges from things like each application being containerized so that if one of them gets corrupted or fails or is accessed, you can't access any other applications running on the device or the machine tool itself. There's no root access to the device, so you can't go in and make changes to things at the root level. And then the last topic I would mention is that one of the other differentiators with our solution is that it's managed via the cloud. So what that means is once you have your edge devices and you're installing them in your machines, you select what tools and applications you want to run on those devices from a centralized database running in the cloud. The applications and tools are then deployed down to the edge devices. And so you can centrally manage, your fleet of devices that you have across your shop floor. You imagine you have 10, 50, or 100 machines. You need to be able to centrally manage them. But we also have the added benefit that we do not require persistent cloud connectivity. So you don't have to have your shop floor connected to the cloud at all times. The number of our customers, they'll connect their devices to the cloud, deploy their updates or applications or what they're going to run, and then they disconnect from the cloud and run their edge device in a strictly local environment, which, especially in the United States, cybersecurity and cloud connectivity are important and sometimes touchy topics. And so having the ability to run without cloud connectivity is a major point that needs to be addressed by anyone who's going to be operating in this market space.
Are there some projects or useful metrics about edge computing that you'd like to talk about?
Yeah, I'll first go over projects. So initially, when we released our edge computing platform, some of our first customers that came to us actually were universities, research organizations. And initially, they're really just looking to collect a high volume of data for a long period of time so that they can start to do these advanced analytics, whether it be statistical analyses, or trying to move into the realm of machine learning in order to essentially start to get big data from the shop floor, which is something that wasn't exactly available in the past. I mean, you could end up having a lot of data if you're working over months, but you didn't have data at the resolution where we're talking at milliseconds, unless you went in with sensors and had to end up streaming that data to your own servers, which wasn't really scalable. So edge computing has really unlocked a new ability for researchers to collect a high volume of data to really start to take a deep dive into what's affecting their machining processes. Since then, we're starting to see a lot more interest within industry, especially in the aerospace and automotive verticals. Right now, we're working with an automotive customer who has an issue with their machines where they have to replace their ball screws fairly often, and they're having to prioritize where and when they're going to replace these ball screws. And so they're using the edge device to collect what we call a mechanical fingerprint of these machines to tell them how is the machine doing in terms of mechanical state. So measuring things like the friction of an axis across its range of motion, the stiffness of the drivetrain, as well as things like equability, which is telling you about the torque across the range of motion, among other measurements. And they're using that in order to prioritize and identify when they should replace these ball screws on these machines. And then we have a customer in our aerospace sector where they're seeing tool breakage sporadically. And so they're now using the edge device first to start collecting data when they're producing parts and not having issues, as well as collecting data whenever they're having these tool breakages that are sporadic, so they can start to identify what's causing these changes and what's causing tools to break when this occurs. And then really the next step that we're going to be working with them on is more so predicting when these tools are going to break or when they have broken, so that they can be replaced immediately instead of the machine air cutting for the rest of its machining operation and wasting essentially an hour's worth of time on the machine when they could go replace it with a sister tool and get back to making chips.
Sounds like some great projects. Were there particular lessons learned or advice that you'd like to share about those or other projects you've worked on?
Sure. Really, the biggest piece of advice I would say is have a clearly defined use case that you're looking to address. In the case of universities, they love collecting data and figuring out what they want to do with it. But when you're in industry, I think people are more results oriented. And in some cases, we've had customers come to us and say, yes, we want to collect all this data, and then we'll start processing it and figuring out what we want to do with it. Problem is, you're talking about collecting gigabytes of data per machine per day. And so you start to be dealing with a whole lot of data that you're going to be storing and trying to analyze and work with. And so if you don't have a use case very clearly defined, that can start to become a bit of a challenge in terms of figuring out how to handle the data. You have to think of it differently than something like cloud computing, because we're dealing with such high volumes of data in a fairly short span of time. So I would probably recommend people to, if possible, take advantage of the tools that are readily available or applications that are readily available on edge computing platforms. Or if not, if you're looking to develop something custom, really make sure you have it clearly defined in terms of what you're looking to do.
Finally, where can someone go for more information about this?
Yeah, so we do have a landing page for our edge computing devices. Honestly, if you're asking me, I'd probably say Google. It's Siemens Industrial Edge for machine tools. If you do that, it should be the first result that shows up in your web browser. And on there, you'll basically get information in terms of the different applications we have available, where they've been applied, and what types of use cases they address, and gives you more of a overview of the platform in general.
Great, and we'll give that URL specifically with the accompanying article that goes with the video, so everybody will have that. I'm being told it's usa.siemens.com/cnc-edge. And so that'll be with the accompanying story. Well, thanks so much, Gus Gremillion, Siemens Digitalization Solution Consultant. I'm Mark Hosky, Control Engineering Content Manager. Thanks for joining us today, and we appreciate your input and your advice about edge computing and automation applications.
Absolutely. Hey, Mark, thank you for having me on.
All right, take care.